Good morning. I'm Tony Paraka, Field Applications Engineer with Coto Technology. Today I want to introduce you to a new line of magnetic sensors based on tunneling magnetoresistance from Coto Technology. These sensors bring significant advantage to product design. Let's look at what an omnipolar sensor does. Once again, let's walk over to the chart and the devices themselves to see how this sensor operates and how it can be used in an application. This chart represents the output from an omnipolar digital sensor from Coto Technologies, such as the RR121-1 XXX, representing different variants available. On the vertical axis is the voltage output from the sensor, and the horizontal axis is the magnetic field strength from an approaching or receding magnet. On the right side is increasing field strength from the North Pole, and on the left side is increasing field strength from the South Pole. The green lines here represent the output from the sensor itself. When we look at this chart, what we see is at this point, which represents zero magnetic field, or a position where the magnet is far away, the output from the sensor remains at a digital high. We say the switch is in the off state. Let's consider a magnet approaching the sensor, and let's say it is the north pole of the magnet approaching the sensor. The field strength starts increasing. What we see here is the output remains at a digital high until a point BOP, or the operate point of the sensor, which generally corresponds to a certain distance between the magnet and the sensor. At that point, the output from the sensor switches from a digital high to a digital low. We say the sensor has turned on. So at the operate point, the sensor turns on. As the magnet approaches further and the field strength from the North Pole increases further, the output remains at a digital low. What happens when the magnet starts moving away? When the North Pole of the magnet starts moving away, the field strength from the North Pole starts decreasing. We see at a point BRP, or the release point for the sensor, the output switches from a digital low state back to a digital high state. We say at the release point, the sensor has switched from on back to off condition. If the magnet is moved further away, as the North Pole of the magnet is moved further away, the output simply remains in the off state. What we see here is if it were the South Pole of the magnet that approached the sensor, we would have a very similar output profile, but on the left side of this chart. These two being identical, we say the sensor responds similarly regardless of whether it's the North Pole or the South Pole that approaches the sensor. For that reason, we say the sensor has omnipolar sensitivity. It responds equally well to the North Pole and the South Pole. It turns on at BOP regardless of whether it is the North Pole or the South Pole, and it releases at BRP whether it is the North or the South Pole. This has great advantage in an application. Because the sensor is completely agnostic to the polarity of the magnet, it offers great flexibility in the installation of the magnet in the product. The magnet can be installed without any regard to what pole of the magnet is facing the sensor. The sensor will operate equally well with both polarities. That's a huge cost advantage for an end applications manufacturing process. So these sensors find ready use in security applications, for example, checking whether a window or a door is left open, a car door, for example, and a number of other applications. Let's now go to the demo board and look at how the sensor operates as we move a magnet closer or farther away from the sensor on the demo board. The omnipolar sensor responds to the North Pole and the South Pole of a magnet. When a North Pole approaches the sensor, the output turns on as shown by the LED. When the North Pole recedes, the output goes off. In a similar fashion, when the South Pole approaches the magnet, the sensor turns on. When the South Pole recedes, the sensor turns on. Because the sensor responds to the North and the South Poles, it is called an omnipolar sensor. For more information on these sensors, please visit our website, www.cotorelay.com. You can download data sheets, application notes, and more information about these sensors. When you're ready to do your product design around these sensors and you're faced with questions about how to optimize the use of sensors, how to select the right magnets, please reach out to us. We are more than happy to work with you. Please send us an email at appsupport@cotorelay.com. We'll respond to you straight away and help you along your way. Thanks so much.